IoT Unplugged, where we talk to industry leaders, innovators, and major players in the Internet of Things, bringing you the best and latest insights. Tune in to learn more. In this episode, I'm joined by ZJ, the CEO of FlowFuse. He talks to me about low-code software, its advantages, and the democratization of IoT and what it all means. Stay tuned. Hi ZJ, thanks so much for joining me today.
My pleasure. Thanks for inviting me.
So to kick us off, could you start by giving a quick introduction to yourself?
Yeah, sure. So I'm Zegian van der Weg, commonly referred to as ZJ because it's a very Dutch name. I live in the Netherlands. I born and raised here, studied, first economics and then law. And then I finally cut my stride and did computer sciences. I was also the kind of geeky kid that built his own computer and then upgraded components. And from there on out, in the end, it's all natural to go into computer sciences. And my first job was at GitLab, which was an amazing company where I left just before the IPO, and from there on out worked on FlowFuse.
So tell me a little bit about FlowFuse, which I understand is the company that you founded.
Yeah, so FlowFuse is an open core company. It's built around the Node-RED open source project, which is a low-code tool to connect hardware to software and build workflows that way and advance automation. So in IoT, this is used to connect the fragmented space of IoT to the cloud and back again and close the feedback loop.
And we will be talking about low-code software in more detail and kind of the role it plays in enabling people who are less familiar with code to build applications. But before we get into that, what are the current challenges to building IoT applications as you see it?
Yeah, so the fragmentation of the space, I would say, is very hard to overcome. To have the connectivity, Node-RED, we have a giant community which connects to all these different styles of hardware, sensors, or digital services. But that does make it much harder for most integrations to be built or most solutions. Furthermore, IoT has the other challenge that compared to like digital native companies that build software for software engineers, for example, there the problem space and the developer are very closely aligned. Whereas with IoT, the stakeholder of the solution is not always the one that builds it. And I think that low code is the way to solve that, where you bridge those gaps by unifying the stakeholder with the solution.
And some low-code software is something I'm hearing more and more from my end. I'm aware it's a world you're very well versed in. Could you give an overview of what low-code software is and how it operates?
So low-code software is commonly the bridge between no-code software as well and high-code software. High-code software is like the black terminal, white letters, or even green when you're really old displays. And then you basically type text. The text is interpreted by the computer into instructions, and it just follows these instructions. It has a very high barrier to entry. So I went to university to actually learn how to do this properly, and it took me 4 years to get a degree in this. As well as like when between 12 and 16, I did a lot of software development already to learn this process. So there's a very high barrier to entry. And even when you enter that world, there's still a ton of learning to be done. Whereas no-code and low-code software use a graphical approach and try to make code and writing instructions for a machine as easy as, for example, building an Excel sheet. And by visualizing this into nodes that are basically connected together, and then transformations happen more visually, it is easier to reason about what systems are connected to what other systems, how this data is wrangled and transformed, and what it means for the end user. And so it's mostly about barrier to entry reduction. If we can decrease it by 10x, that means that more than 10x people will join into automating their job.
I mean, speaking anecdotally, I was in conversation with someone about how some engineers are using AI to help them code. So there certainly seems to be a need for these kinds of tools and software, which is interesting. And I guess I wonder why that is.
So I would say that AI for writing high code these days is very good at writing boilerplate. but you still need a lot of manual verification. So you still have the higher barrier of entry where you need to verify that whatever the computer wrote is still what you need. And then why use these tools? Like it's mostly about productivity. As a developer of any solution, the hardest part is actually going from an idea to something that you can implement. The thought in your mind is taking much longer than it is to either type the code or drag and drop the solution together. So that's the real productivity gain to be had for the whole space. Like tooling at the end of getting from idea to production is actually, I would say, 20% of the time spent. The first 80% time is just POCs, understanding the problem space better and better, being intimately familiar with who the stakeholders are and what their demands of the solution are. And low code is especially good at making the barrier to a POC much lower and then bringing that POC to production much faster.
So bringing it back to IoT applications, in your opinion, do you think software has become more complex, which has kind of driven a need for tools that help with coding? And if so, why do you think this is?
Has it become more complex? I would say IoT is too young to talk about increased complexity. If you deploy more solutions, you get higher I'm sorry about that. If you deploy more solutions, you get a higher variance of the solutions. We should not mistake variance with complexity. I don't think IoT is necessarily much more complex than other solutions being built out there. It has unique constraints and unique demands, but it's not more complex.
And so when we talk about building IoT applications, what are some of the challenges that you see from your perspective and your job at FlowFuse?
So it's a build versus buy decision, first of all. So if you buy a solution, you might be buying a solution that was great for the last buyer and was optimized for that last buyer, but for your situation, it might or might not fit. And so then the question for the organization is building better? Do we have the right people in the organization? Can we actually ship this? Can we also maintain it afterwards? Then the maintenance part of applications, I think, is underserved. So if like the decision to build an application is very easily made, but also consider how are we going to maintain this? What are the future demands? And how are we going to keep up with the requests that all the stakeholders of this solution will have?
So let's talk about some of these existing solutions. What are some of the solutions you see on the market? And following on from that, what are the solutions that you at FlowFuse offer?
So there's a lot of point solutions already available. So if you have a precise set of hardware or you are very bought into one vendor, then generally those vendors also will supply you point solutions for your common IoT problem sets. We are much more in the low code, build it yourself area. So you can actually align the software you're building with your problem space. And so the solution and the process are very closely in sync with each other, versus where point solutions generally apply. Yeah, you apply a point solution and sometimes you need to update your process or your organization to fit the software you're buying instead of the other way around.
And you mentioned when I asked you about the complexity of code, you mentioned IoT being quite a young industry, which it certainly is. So do you think that we're still at a point where we're seeing the gradual adoption of low code and no code? Do you think in the future they might become more popular? Is that something you can comment on?
Those are not mutually exclusive. I would say we see more and more low code and more people building IoT centric solutions. It's much easier than it has been. Like if you're the first one, there's always the biggest hurdle. The second one has a slightly less hurdle. I would say it's almost a flat surface right now to build IoT solutions. And the complexity of IoT are well described and understood. And there's abstractions available to most of the problem sets. And then I see the biggest hurdle actually being efficient ROI centric solutions. So having a problem that delivers ROI in a time frame that actually makes sense for companies is one of the more organizational hurdles to be crossed right now.
And you mentioned earlier about productivity. So I feel like, particularly when we look at IoT applications, the pressure to have something with a short time to market probably ties in with that.
Yeah, definitely. And also making the problem space small enough that you can actually deliver something of value really quickly. We generally like to see paper in offices or in organizations that buy our software because those are dead giveaways that there's something to optimize. And it's very visual, very physical, and measurable. Like, let's say you have a feedback form that happens after every month. Now, if you make that a form through an email and you have productivity gains, it's measurable, you get more insights, and you're going to record that whatever's on paper in a database somewhere anyway. Now it's just much more efficient to get that done. So those are pretty much the easiest wins. Secondly, dashboarding of data. There are so many hunches that people walk around with on a day-to-day basis about their environment. If they just had access to the data and can whip up a quick dashboard and just understand, like, this one idea in the back of my mind that's been bugging me for the last 6-7 weeks, is that actually a great idea, or should I disregard it right now? It's generally done through a dashboard. So dashboards are great for getting very high ROI for your team.
Yeah, it's just a great example of how the integration technology has just, I think the word you used was hunch, which I really like. It's removed a hunch and actually verified whether something's worth the time.
Yeah, yeah, and hunches verification need to be really quickly. If you're going to take 6 weeks to verify a hunch, like, it needs to be much more than a hunch already. So again, like, it all comes back to ROI.
Great, thank you for that, CJ. So following on from the kind of things we've spoken about with low code, with how it's being used as a supporting tool, something I'm hearing as a term, or is being used a lot, is the democratization of IoT. So could you describe a little bit what that term means and how low code software fits in with it?
Yeah, so demos in Greek, like, it's village, town, or people. So in broad paint strokes, this is just bringing the technology and technology building to the people or to the town. And what we're mostly seeing is, like, the stakeholders, if they have to file a ticket to a developer in an office hundreds of kilometers away, there's just such a distance between, other than physical, like a mental distance between an idea and getting this idea in production. They might not even record this idea. And so the key property for democratization is, what if we can make the hurdle to get this idea into production not like filing a ticket, but giving them the tools to try this, to do on the edge, like where the actual stakeholder with the problem is. The time to value is much smaller. The stakeholder is also responsible for the actual solution, and therefore you get a better and faster solution. And better, like, this might mean you get a visually less pleasing solution, or you get, like, there's other trade-offs. But for a first POC or for a first solution, this is generally always better, just because you have a solution. Like, there is something to improve on, versus ideas that are lost are just wasted. There's just no, especially if they're not captured in your Jira or your other issue tracker for the developer. If the hurdle's just too high, all this knowledge is going to be lost in your space.
And it's something I see a lot in the IoT community. It's slightly different technology, but it was with regards to open source in terms of giving people the tools to kind of address some of the issues, and then knowledge sharing, which I think is a really great part of the community.
Yeah, definitely. Without the knowledge, you can't build a solution. So again, like, how do you get the knowledge into someone's mind that can have the idea, and from there on out, how do you get that into realization into a solution? And low code software is precisely the tool to do that.
Absolutely. So what are some of the applications that you've seen come out of using low code? Are there any particularly example?
Yeah, sure. The coolest thing I've seen so far is on the manufacturing floor, actually, where replacement parts for stations are ordered. So you need to basically understand like what are the parts we need to order, where are those located, and then you need a forklift driver, the forklift that can actually lift this pallet. So you have quite a complex problem. And then I walked around the factory floor one day, and a customer had an Uber for forklift trucks that did precisely this. A very simple app, like these are the parts I need, and I need them by this time. And then on the back end, they built the whole solution themselves. These are not computer scientists majors or anything like that, no PhD in anything. And that's surprisingly what took me off guard. As a computer scientist, the first thing I was doing in my mind is like go through all these algorithms, like how would I build this? And I figured I just don't know within 20 seconds. I just don't know how I would approach this problem space. And here I was walking around with a solution that is just fully functional and might not have the best complexity time in terms of compute, might not be memory efficient, but the true value of the solution was already deployed. So that's the coolest thing I've seen. Then just the ease of dashboards, to go back to dashboards, like how easy it is to just, I have this hunch, I have this idea. What I need to do is combine these 5 data sources, get me all the historical data for these 5 sensors. Let's combine those in a quick and dirty dashboard, which I might just throw away 10 minutes from now. But still, like doing all this data rendering, doing a quick analysis. I always like those solutions.
And I think a lot of people are visual, so just having it in front of you probably has makes a world of difference.
Yeah, exactly. And especially even if you are not visual yourself, getting this idea across to your manager, to your peers, visual is just way quicker. And also this is shareable.
So you mentioned manufacturing in the example you gave of an application you've seen benefit from low code software. I was curious, in your role, are there any particular industries that you see benefiting from it, or is it really just a wide range that all approach it differently?
Our go-to market as a business is around the open source community, and the open source community has literally taken it anywhere. So we've seen banks integrate the physical reality of their business, so with plastic cards and other things as well, into their support ticketing system. We've seen manufacturing all the way from discrete manufacturing to process manufacturing, gas, oil, solar. So it is very vertical agnostic. The common denominator is that they have a lot of data sources, sensors, SaaS systems, machines, and they need to combine all these data sources into something useful in a new solution.
So with everything that we've spoken about, CJ, what are your key takeaways for companies building IoT applications?
If you give your people the tools for the job, they'll get you surprising results. Like the forklift, the Uber for forklift trucks I just talked about, that's not something that will ever be top down into your organization. So innovation will happen bottoms up, and you need to enable your team and your current engineers, whether they're computer scientists or they're mechanical engineers, electrical engineers. All those engineers need to be enabled also to be software native and build software solutions.
Great. Well, thank you for that. Before we wrap up, is there anything else you want to mention to our listeners? Any final comments?
Obviously, the company, so visit FlowFuse, but otherwise, no, not really. Nothing to promote. Thank you.
All right, great. Thanks, CJ, for being here. It was great to talk to you.
Likewise. Thanks a lot for your time.
IoT Unplugged.